talk 5 minutes before, probably now. It's also a tough task to keep your attention alive after the post lunch. I have little bit of experience with the students now, so probably now I'll try some tricks here also. So maybe by the end of this next 30 minutes talk, we can expect to answer a couple of questions. One question is that why Apple, the latest Apple phone, claims that it has a haptic feedback is not true. Okay, so many of you must have experienced that Apple phone claims, the latest Apple phone claims that it has a haptic feedback, it has a haptic engine. So I'm going to probably by the end of this talk, you would understand why that claim may not be true. We are not going to sue Apple, but not just for understanding. I run a lab called a Touch Lab in IIT Madras. It is a unique lab in India where we focus on studying our touch sensation and develop technologies to provide touch feedback in virtual reality environments. So in next half an hour, we will talk about what are the research challenges in providing touch feedback, specifically in virtual reality. And my focus application is medical simulation, where there is a lot of touch interaction is required. Although the technologies we develop could be used anywhere else. So there are three parts of my talk. In the first talk, we'll talk about what is the current status as far as the haptics in virtual reality is concerned, what are the challenges in there, and then the second part I will talk about the medical simulation applications, and then third part I am going to talk about what could be the ultimate virtual reality, augmented reality with the haptics. Okay, so uh, to start with, here is a definition of what a virtual reality. This definition is very important for understanding the nuances of the haptics definition. I consider the definition of virtual reality is basically based on two pillars. Two pillars, one pillar I call it as a immersion, the other pillar I call it as a interaction. There are two eyes for virtual reality. One eye is the immersion and another eye is for the interaction. Take up any application, these two eyes will be there. Unfortunately, since we are in the beginning of the VR revolution, we are most focusing on the immersion, not on the interaction. Interaction is very little in most of the application which is coming over here, except the games they may have more interactions. Okay, immersion also can be visual immersion or haptic immersion or different kinds of sensory immersions possible. So again, we can call it as a whether there is a full immersion or partial immersion. I call it as a 5. 5 is for fully immersive virtual environment. 5 is for partial immersive virtual environment. Okay. So similarly, the interaction also can be fully interactive or not partially interactive. Based on this is definition of virtual reality, people have classified virtual reality systems. There are many virtual reality systems, right? There are based on the immersion alone, the classification can be different. Based on interaction, the classification can be different. The same set of VR systems can be classified into another system based on interaction or immersion. For example, I am going to highlight something like the cave, right? The cave is a room-based virtual reality system. This can be considered as a interaction-based virtual reality, whereas this cave could be based on the. So as far as the immersion is concerned, now the cave could be part of the fully immersive system. But as far as the interaction is concerned, cave could be part of the partially immersive systems. I'm going to explain to you now slightly later, but I just wanted to emphasize that interaction and immersion can make a lot of difference and in classifying the virtual reality systems. Again, looking little broadly, virtual reality systems is not just a computer graphics or mechatronics or robotics or biomechanics. It is a highly interdisciplinary field. Specifically, in IIT Madras, we emphasize on the psychophysics part of it because focus is on the human perception. In virtual reality, the center is the human user. It is not the any other engineering object or engineering instrument which we are talking about designing. The design is for the user. The human perception is important. It is not the head-mounted display hardware, or it is not the software. It is a human user. So, because we are talking about the human user, we need to understand the human perception very well. How do we understand the human perception? That subject is called the psychophysics. So, if you want to excel in virtual reality, designing better virtual reality systems, we need to understand the human perception well, and therefore the psychophysics. I offer a complete course, 1 semester course in virtual reality in IIT Madras, and our whole focus is on the psychophysics in order to help the students to build better virtual reality systems. By the way, this virtual reality system is also available online. Many of you may have heard about the NPTEL. You can look for NPTEL courses on virtual reality. I co-offer this course along with my colleague from UIUC, Armana Champagne, who is now one of the inventors of the Oculus, right? So, I just wanted to explain to you where this human perception is making a lot of difference. If you look at the center square, the right center square looks brighter, whereas the left center square looks darker. So it is just a human perception. Whereas if you look at it, is it? No, I think there are two slides skipping. How do we skip only one slide? Excuse me. There are two slides skipping. How do I skip only one slide? Okay. So if I want to skip only one slide, not 2 slides. Is there any other interaction? Yeah. Yeah. So, psychophysics is nothing but is a measure of perception. Unless we measure perception, we cannot design better systems. Measurement is the first step in any of the engineering or even science, right? So, how do we measure perception? Perception is a mental event. It is not a current or voltage or weight or something physical thing, right? So, how do we measure the mental event? That is a whole challenge of the psychophysics, right? So, here the idea is that if we measure stimuli, that is the visual stimuli or the haptic stimuli or auditory stimuli, and we can find out the relation between the perception, that relation, finding the relation is what called the psychophysics, right? Next slide, please. Yeah, this is an example. So here the center square, which is brighter, and this side is lesser, brighter. Next slide, please. You can see that the center center square is the same intensity, but the background makes a lot of difference. So how do we quantify the factors affecting this perception? Okay, quantifying these factors is what the psychophysics is. Okay, we are looking at only the brightness. Brightness is one of the psychological factors as visual psychological factors, right? So the law which is defining the brightness perception is called the psychophysics of the visual affecting this brightness, right? Similarly, we can talk about the haptics. Next slide, please. Next slide. Yes. So similar to the visual, there are also haptic perceptions which we are going to talk about. That's what our focus is going to be. Providing touch feedback in virtual reality is one of the grand challenges. So that is going to be the grand challenges probably 5 years down the line. Next slide, please. So haptics, just for brief introduction, is a science of touching, uh, similar to the vision, which is a science of seeing, or auditory, which is a science of hearing. The basics of haptics is biomechanics of the skin, for example, similar to the acoustic as the basis of the auditory, or optics as the basis of the vision. Right? Next slide, please. It's working? Yeah. Okay. So the biomechanics is very important because there are many sensors in our skin which converts the deformation while we are interacting with the objects into neural coding and then send it to our brain, which is where we are perceiving the haptics. Haptics is actually not only sensing but also object manipulation through touch. Okay. So the Apple mobile phone, which is talking about the haptics engine, if you look at it, so it knows all of our cell phone also, not only Apple, any cell phone, there is a touch sensing. It is not a touch feedback. It can only vibrate a little bit. Vibration, we are going to see that it is not a haptics feedback. Okay. So haptics is not only sensing but also object manipulation. It should facilitate manipulation of the object. It is not just a vibration. It can be not only by human, it could be also by machine. It also not only in real but also virtual and teleoperated environments. So haptics can be between machine to machine, human to machine, or human to human. Right? So it could be human to machine to and then back to human in a teleoperated environment. So we have done psychophysics of these haptic systems and measured a lot of parameters and then put it in a specification sheet like this. So this is like a technical specification for our haptic system, for human haptic systems. Just like you have a technical specification for your chip, IC chip, or any engineering component what you buy, or any object you buy, or any instrument you buy, right? You have a technical specification. With that technical specification, you can use it to design better applications, right? Similarly, we have come up with a technical specification for our haptic systems, and this could be useful for designing better haptic systems. One example I can give you, for example, if you look at the frequency range, it is 1 kilohertz. On this computer projection screen, it is flickering at 30 hertz, which we don't feel it because our eyes have a limitation in perceiving the flickering. Our eyes merge two images if it is flickering faster than 30 hertz. Similarly, our skin merges vibration if the vibration is more than 1 kilohertz. If it is vibrating more than 1 kilohertz, we don't feel the vibration at all. That is one of the limitations. So this could be useful to design force feedback systems, haptic systems, right? Similarly, there are so many other factors coming into picture, right? For the interest of the time, I am skipping all these things, but the specification sheet is there, is what I wanted to tell you. So the current state of the art as far as the virtual reality, what are the challenges over here? I'm not going to go into the details of it because the focus is on the haptic systems. The software also, there are challenges. In grand technical challenge in the virtual reality is the VAC, Vergence Accommodation Conflict, right? So that is a very well known and conflict as far as the virtual reality is concerned, and it may not be, it is inherent in all the virtual reality systems. Similarly, in haptics also there are some conflicts. That is what our research finding is. I will focus on the grand challenges as far as the haptics. If you want to develop a system for giving force feedback, that system should not add weight to already existing weights in the hands of the user. Okay, so bare hands, we should be able to use it, and then still we should be able to give feedback, force feedback to the user. That is not possible, right? So if you look at all the head mounted displays, right, it weighs about 2 kgs, and you have to hold this 2 kgs of HMD, maybe 1 hour, your head will get fatigued, right? That is one of the challenges. So we have to reduce the weight of the head mounted display as much as possible. Ideal is, no, without any head mounted display, can we give a fully immersive fully immersive virtual reality? There is a huge challenge, right? That is what the Facebook is looking at it. Facebook wants to come up with a very smart glass kind of things, but still the user will feel fully immersed, right? So similarly, haptics, without adding any inertia, we should be able to render maximum force, not only small force, but as much as force can we render. Gloves is one of the promising things, but the existing gloves, if you look at it, it's all very bulky. If you wear it, you have to really move, add a lot of force in order to move with the gloves, which itself is killing the realism of the haptics over here, right? So without the gloves, can we give the feedback, force feedback? That is a whole challenge. Or no, minimum, what is the minimum mass needed in order to give you the force feedback? Okay, there are a lot of graspings which we need to provide in the virtual reality. At least few of them. How much inertia is needed to provide each of these graphs? That is the research we need to find out. There are currently existing technologies which will provide you force feedbacks. For example, if you look at the grounded haptics, this has a limited workspaces. It can be put it in a place, and it cannot be useful for very big virtual reality systems. The second one is exoskeletons. It is very bulky. It adds a lot of weightages. The very recent one, last couple of 2 years or so, fingertip haptic devices are coming over here, but again, the kind of forces it can render, it's very limited, right? There are again, in the last 2-3 years, there are indentation devices coming over here. It's a fingertip added. You can see that again, mass is added to the fingertip. The fingertip can hold only very little mass. It cannot hold a lot of mass, and again, it cannot hold it for very long time, right? So there are a lot of health effects of the virtual reality and augmented reality. For example, vection, and there's an illusion of self motion, or the motion sickness, cyber sickness, right? So there are simple methods have been developed to avoid it, but most of the demos over here, it provides motion sickness as probably here in our lab we have developed our own haptics based systems to reduce the vection. If you are interested, you can get in touch with us. There are direct health effects, there are indirect health effects. Indirect health effects, we do not know, since we are just starting the VR revolution. Probably we'll have to wait for some 5 years or 10 years in order to find out what is the social effect. For example, if you are getting used to the now and shot in the virtual reality, right, how will that behavior affect in your real reality? We do not know, right? But there are a lot of applications. So for example, one of our collaborators in UCL London, he is using this virtual reality technologies to embody to somebody else. For example, he is making you to believe that you are Einstein. Once you believe you are Einstein, your IQ is improving. Okay, these are the lot of advantages over here. So the second part of my talk, I wanted to talk about a little bit of medical applications where we have developed in our lab. We found that stroke rehabilitation in virtual reality based on the haptics can be much more effective compared to the traditional method of stroke rehabilitation. Okay, we are working with Sri Ronald. in Trivandrum, and we have put in and use, and the patients there in Sri Trinal, they are using it. So this idea we are scaling it to other rehabilitation requirements like autism and other psychiatric diseases, wherever the visual effects and the haptics effects are required, we are trying to use this technology. Okay, again, more than the some of the places, visual effects is much more convincing than the haptics, maybe 60% or 70%. Okay, and then the next set of simulations applications, we are talking about the helping doctors learn clinical skills, because for doctors experiential learning is very important. They have to touch and feel everything. Without touching and feeling, the training is not complete, right? So that is where the touch is very important. We have developed a couple of systems, and it's all some of them are getting ready, some of them are finalized. It is taken to the market. One good example is this epidural injection simulator. It is one of the very dangerous procedure given to labor women in their labor time to reduce the pain. It has to, the needle at the spinal cord from the back, it has to go through 7 or 8 layers in order to reach this space called dura. Only in the dura you can do the injection of the analgesia, so that so that the patient alleviates the pain. But if we overshoot the needle, it is going to puncture the dura, and all the CSF, cerebral spinal fluid, which is going to leak, and then we'll have a lot of complications after 6 months, not 10 months, after 6 months. Okay, so the training is very, very important, and it is a completely blind procedure. We are using the virtual reality and haptic technologies to give training to the anesthesiologists to reduce the risk involved in the patients. Okay, so we have come up with some models of the skin, and where the doctors can tune the force perception by themselves, adjusting the force perception with their experience, and then show to their junior doctors or trainees. The second one is the laparoscopic surgical simulation with the haptics feedback. So in the laparoscopic surgeon, you can see that there are 2 trachars over here. Each trachar is a 5 degree of freedom robotic, highly advanced robotic device, which provides a touch feedback, and they can see it in the either desktop or in the virtual reality environment, but the focus is on the haptics. This is completely developed inside IIT Madras. And then another simulator is the in vitro fertilization simulator. The in vitro fertilization is again a very fine haptics motor skill is needed for successful procedure. Okay, so I was told that there are at least 30 patients are harmed before the doctor gets competent with the procedure. So in order to save those 30 patients, we have developed this training simulator with a haptics feedback, and this has been now given to one of the Singapore company, and they have validated in the Singapore General Hospital. Then we are right now developing with Tamil Nadu government for neonatal resuscitation training simulator. There is a golden hour of as soon as the baby is born. There's a 10 minutes, first 10 minutes the baby has to cry, otherwise it will die. So within 10 minutes, what are the first aid procedures the baby has to be done? So this is a training, and this has been completely simulated wherever touch feedback is necessary. Okay, only there we have introduced some haptic devices. We call it as a minimally immersive haptic devices. So they are using the real tools, and then for example, this bag and mask, what the patient or the trainee is compressing it, it is on the virtual patient. The trainee gets a real haptic feedback. They are using the real tools, but they are using the virtual patients. Okay, that is a challenge of providing haptics. Okay. Similarly, CPR training. CPR training, many of you have heard about it, where we have to compress the chest 100 times a minute, 5 centimeters, and with the complete recoil. This is now haptic training. It is nothing but the haptic training. This we have done it in the virtual reality with a minimal haptic device, and this is called the advanced cardiac life support training. All the doctors are supposed to get trained, and again, wherever it's completely done in virtual reality, wherever haptics is needed, we have done only minimal haptics. Okay, so that it becomes much more affordable. So there are currently mannequins are being used for training. Such a highly advanced mannequin cost about 1.5 crores to 2 crores, whereas virtual reality based systems we can make it much more affordable. Right. So these are the other simulators which we are on the process of developing it. For all these procedures, we have developed our own haptic device which will go into each of these simulators. This is one of the first haptic devices developed in India. It has a 3 degree of freedom force feedback, 6 degree of freedom sensing, and 10 millinewton meter torque, which is quite sufficient for any of the medical simulation procedures. Okay. So given this applications, challenges and applications of the haptics, let me spend couple of more, maybe couple of 3 or 4 minutes on ultimate virtual reality. What could be ultimate virtual reality? We are talking about the current systems and the future system. What could be the future most ultimate virtual reality systems? Okay. So ultimate virtual reality system is something like virtual reality experience without any of these gadgets. Imagine without the cave or without the HMD. Okay, can you feel the immersiveness? Right? So that could be the ultimate virtual reality systems. Right? Similarly, haptics also. Without any of these gadgets, I can provide force feedback. That could be the ultimate one, right? That could be the dream, right? So engineers are here to dream about it, right? Only when we dream we can design such things, right? So that is a part of the our research we are talking about. To achieve this ultimate virtual reality systems, we have to have the specification of the mind, because the whole virtual reality is about perception, right? So it is a fooling the brain. If you can fool, only when you know the specification of the mind, you can fool the brain better, right? So do we have the specification of the mind? Do we have the specification of the knower or the perceiver? Not yet. Okay. So fortunately, we in India, I believe, coming from the Indian community, I believe we are in a better position to specify the mind, knower, or perceiver compared to the Westerners. Okay, so our society, our culture, we we call this mind, knower, or perceiver something called God. So there is the concept of God. It is very nice concept, but unfortunately, it has been given a religious color to it. It's a highly scientific concept of God. Okay, so we keep this concept of God in the temple, but actually it is nothing but the specification of the mind and knower and perceiver. Okay, so from the scientific point of view, if you look at the concept of the God, which I think India is the leader of, it's a spiritual capital of the whole world. There is nobody else in the world better capable of understanding the mind than anybody, right? So we have almost all the knowledge. So I think the future of virtual reality is in India. Okay, I believe now we can develop better virtual reality systems than anybody in the coming days. So we did very small experiment towards this, and there could be a lot of experiment we are planning in the coming days. For example, here is a phenomena called hypnotic analgesia. Okay, so here is one of our collaborators in Harvard. He is a psychologist. He shows color photographs to the patients and then makes the patient see black and white photograph. And he does the vice versa. He shows a black and white photograph to the subject and makes the subject to see the color photograph. It is just a fooling the brain, but there is a way of making it happen. Now, how do we make it happen without any gadgets? There's a whole challenge. So, according to the Western science, this concept of mind doesn't exist. Hypnosis is actually it's a black box because we don't understand. But fortunately, Western science understands or accepts that hypnosis is true. But only thing is, it doesn't know why it is working. Okay. Um, uh, we have done similar experiment over here, hypnotic analgesia. We do the injection, real needle injection onto the 10 subjects, and then hypnosis the subjects. When they are hypnotized, they don't feel the pain, even if you inject it. To achieve this ultimate virtual reality, the specification of the mind, the knower, and the perceiver is needed, and we have to get these specifications just like the way we have done for the haptics. And there are also specifications for the visual, and auditory also is a highly extensive research is there, but mind is not there, and that's where the future is. Once we have it, we'll have the ultimate virtual reality systems. I will stop here. I'll take questions. Any questions? Thank you.
Hi, my name is Firoz. I'm from Novartis. First of all, thank you so much for giving an overview of the haptic systems and the simulators. My question is on what are the challenges, because you have shown a lot of simulators in healthcare. What are the challenges that you have currently in order to develop the haptic systems, especially for the healthcare industry?
So, haptic systems, again, as I mentioned, developing an haptic device is actuator. The whole haptic device is based on an actuator. It is not just such sensing, it is also actuating, right? Coming with a right actuator is the most important challenge in haptics. So we have been working in haptics for last 30 years. If you ask me to tell you one challenge in haptics, that is the actuator. Okay. So right now we are using the DC motors with a lot of constraints. We wish we have an ideal actuator for haptic devices. That actuator is not there yet. So it has to be lightweight, it has to be small, at the same time it has to develop a lot of force. That is a challenge.
Okay, and there are a lot of other. I mean, I have seen some, haptic suits that
Yes.
are available these days.
Right.
Where you feel like vibrating or
Correct.
force
Yes. Yes.
or something kind of this. And how
Yes.
does that work in terms of healthcare or whatever the industries?
Yes. So again, to coming back to this Apple no, climb of haptic engine, right? So maybe I have skipped one of the slides. Haptics is not just sensing, but also manipulation. It has four sub modalities. One is the tactile modality. Since Dr. Neeraj is sitting over here with a medical background, he can tell you. So there is a tactile modality, there is a kinesthetic modality, there is a temperature modality, and there is a pain modality. This four together is called the touch sense. Sensing itself, there is a four. And then sensing plus motor systems together is what the haptic system is. Okay, so this Apple system is using only the tactile and a little bit of a vibrotactile system, not the kinesthetic system. Therefore, we should not call that as a haptic system at all. It can be best called as a tactile system, not the haptic system. So, similarly, the suits you are talking about, it is mostly only a tactile systems, not the haptic systems. Tactile systems can give you only the sensing input most of the time. You cannot develop force feedback. If you want the force feedback, then we have to go for the haptic systems. Again, the limitations with the actuator comes into picture. Okay, yes,
Thank you.
welcome.
Hi.
Hello, sir. This was very different topic altogether, and it's very critical at this stage that haptic is much more required in uh, augmented reality, virtual reality, and other intercommunication stuff.
Yes.
Uh, Considering that, is it completely game changing like time? Do we have to consider it like a very different way? We have to take a different approach, radical change altogether in designing haptics as from the material sense,
Correct. Yes.
from biosensing
Right.
kind of design that human has,
Right.
because now we are like searching a solution where using machines and materials,
Yes.
are we able to design haptic mechanism, or do we have to do something radical change in
Yes.
bringing that devices using some bio chemical kind of approach or biosensory design itself? That
Yes.
is the way where we can at least get
Right.
very lightweight,
Yes.
intuitive kind of mechanism,
Right. Yes.
right? So what is your view on this aspect
Okay,
like?
so to provide haptic feedback in the virtual reality, there are a lot of approaches. One is the materials approaches, robotic approaches, or bio approaches, and there is another approach which I would like to mention it. In visual systems, virtual reality, we do a lot of cheating tricks in order to fool the brain. Similarly, we can do a lot of things for haptics also to fool the brain. So what are those haptic tricks? So there are a lot of tricks we have developed in order to fool the brain, but at the same time give you the haptics feedback. So it is not necessary to have these devices, gadgets. Without these devices also, we can give you force feedback.
As these devices may have limitations,
Yes, definitely, yes.
to overcome the limitations, maybe as you said, the other way around, like the God concept, the mind perspective, or the hypnotism, all these different arena altogether, which science, it goes parallel with the science,
Correct,
but
yes.
still science may proceed research into that area and come up with some kind of mechanism
Right, yes.
or channel to connect through. Is there a possibility there? What you see, like as from the scientific perspective towards the spiritual or towards the energy that we call it the God? Like,
Correct, yes.
what is the connection? Like, what's your view on this? In
See,
fact, this is something different question. In
correct.
fact,
Probably
uh,
the spiritual questions we can
yeah,
take
we
off
can
the
take it
stage.
offline, right?
Yeah, right.
Yeah.
That will have to be the last question for now.
Yes.
So now we're going to take a quick short break, and the next session is going to start in another 15 minutes. So I just hope to see you all here again.
Thank you. Yeah.